Hello, I'm Dave Casler, amateur radio call sign KE0OG, your guide through the ARRL license manuals. The videos in this course follow the manuals section for section. You can get the ARRL license manuals from the source listed below the video. After you watch the video, dig into the corresponding section of the book, study the associated questions, and then come back for the next video. I'm Dave Casler, amateur radio call sign KE0OG. Hello and welcome to the amateur radio technician training videos. Okay, with this video, let's take a look at section 3.3 on radio circuits. The section starts out with a sentence left over from the previous edition. It says, among other things, that we've already talked about bandwidth and sideband. Actually, those will come in Chapter 5. But we will talk here about oscillators, amplifiers, modulators, and mixers. The conceptual leap in this section is simply the block diagram. The block diagram uses boxes to indicate various functions that can be done. Usually, a block diagram has defined inputs and outputs. Block diagrams can be at any level of abstraction that you want. For example, in section 2.2, a block represented an entire transmitter. In this section's figure 317, there's a simple block diagram of a Morse code transmitter that shows parts inside a transmitter as blocks in their own right. The first important block is the oscillator. That's the name of the function that puts out a steady sine wave-like continuous radio wave at a single frequency. It used to be that good oscillators required lots of components and careful temperature control. Nowadays, you can get several oscillators on a single chip. Some scientists spend their entire lives studying the innards of oscillators. We'll leave the details to them and simply create a block called oscillator, and the output is a radio wave. After the oscillator usually come several more circuits. One such circuit is an amplifier, which makes the radio wave stronger. A simple radio circuit consisting of a single oscillator and a single power amplifier is called a master oscillator power amplifier, or MOPA, and was very common in old tube radios. Modern radios don't incorporate expensive tubes, but rather cheap integrated circuits, and so at the same time can be more complex and yet less expensive. By convention, the last amplifier stage before sending the signal to the antenna is the final amplifier. If it takes a couple steps to get the signal boosted enough, the final amplifier is the power amplifier, and the block just before it is the driver. Not all amplifiers are drivers, but all drivers are amplifiers. An ordinary continuous radio wave will sound like dead air on a radio. Nothing, no signal, just a blank. However, we can modulate a signal or information onto the radio wave in a variety of ways. That way, in an appropriate receiver for that form of modulation, you get the signal, meaning what you want to hear. The basic radio wave that carries the modulated information is called, appropriately enough, a carrier. The signal waveform, say, for example, your voice, changes the carrier in some fashion so that at the receiving end, the signal can be extracted and sent to, for example, a loudspeaker. Just to be clear, the signal is what you want to hear, and noise is what comes through that you don't want to hear. We'll discuss modulation techniques in Chapter 5. One last type of function is the mixer. Now this is quite different from this type of mixer, which actually just adds audio signals together. A radio mixer is a device that multiplies two signals together to create two new frequencies. If the inputs are frequency 1 and frequency 2, the output consists of the original signals plus the sum of the frequencies 1 and 2 and the difference. While this sounds like a really complicated thing to do, it turns out to be quite simple. But let's take an example of where it can be useful. Let's suppose we want to hear a signal that's been modulated onto a carrier at 14 megahertz or 14 million hertz. We combine that signal with one at 13 megahertz. The result is 14 plus 13 megahertz or 27 megahertz, and the other at 14 minus 13 megahertz or 1 megahertz. By the way, you should know this works on the transmit side too. If you need to raise a frequency, say from 14 to 21 megahertz, you mix in 7 megahertz to the 14 and get 21. People spend their entire lives studying this process, but we've studied it enough for the tech license. Be sure to share on social media that you're learning about ham radio. You may find several friends who are also doing the same. Thanks for following along with the videos and the book. After you've studied this section in the manual and are satisfied you understand the questions and their answers, come back here for the next video. The ARRL is the National Association for Amateur Radio, and I urge you to join, even if you don't have your license yet. That way you get QST, the League's monthly magazine full of articles for beginners and veterans alike, or you can choose On the Air, a magazine designed specifically for those new to amateur radio. Until we next meet, 73.